What's up folks, back with another exciting video, that is the gradient boosted decision tree. Let's look at its introduction. Gradient boosting is a machine learning technique for classification and regression problems. So this is a boosting technique. You can refer to the name. It's a boosting technique and it's used for both classification and regression problems. Think that decision tree doesn't work for that type of data and you need to use a tree, you can't use a random forest. That time this algorithm helps you out, that is the gradient boosted decision tree. So this is the data that we'll be using for the example, that has age, square footage, location and their price. The step 1 for predicting is calculating the average. So after we take the whole average of the price, we get 688. You can see 480 plus 1090 plus 350 plus 1310 plus 400 plus 500 divided by 6. The total number of values is 6, so we divide it by 6. And the result is 688. Second step is to calculate the residual values. The residual values is similar to the accuracy but not accuracy. Let's see how's that. The formula for it is residual is equal to actual value minus the predicted value or the mean. So here we don't have any predicted value, so we're going to take the mean. Step 2 is to calculate the residual values. The residual value is equal to actual value minus the predicted value or mean. Here we don't have the predicted value, so we're going to take the mean. So it's going to be 480 minus 688, that's going to be minus 208. And then we have 1090 minus 688, that's 402. And we do the same thing for the others. And we get these values. And then step 3 is to construct a decision tree. You can see here we have all the residual value. For at the top we have the square footage and then we have the location and the age. So step 4 is to take the mean if there are more residuals than leaf. You can see here we have more residuals, that's 380 in one leaf if you have more residuals. So we're going to take the mean and mean is going to be 388, that's the first value, and minus it's going to be minus 388 plus of minus 288. So mean is going to be 388 minus plus of minus 288 divided by 2. That is going to be minus 338. And then we have another mean over here, that's 402 and 622. So we're going to do that. 402 plus 622 divided by 2. That's 412. Sorry, that's 512. And then if you construct a new decision tree, you're going to get it out like this with having one residual in one leaf. Step 5 is to predict the target label using all the tree within the ensemble. The formula for this is average price plus the learning rate multiplied by residual. So it's going to be 688 plus 0.1. Here we're going to take the learning rate as 0.1. You're going to get it as 1.02. So I'm going to say 688 plus 0.1 multiplied by minus 338. So step 6 is to compute the new residuals. That's going to be 350 minus 654.2. That's going to be minus 304.2. The step 7 is to repeat the steps from 3 to 5 until the number specified by hyperparameter. That's also the number of estimators. So from the step 3, that's constructing a decision tree and then take the mean if there are more residuals than leaves, construct a new decision tree and then predict the target label. So we're going to repeat them until we get the number specified by hyperparameter. We're going to do this for getting the predictions near the actual value. So the best hyperparameter is going to be 0. And then we have step 8. Once we train this whole thing, make the final predictions. We're going to say average plus learning rate multiplied by residuals plus learning rate multiplied by residuals. We're going to repeat it with number of residuals. It depends on the number of residuals. And yeah, here we have the predictions. So now let's go and check it practically. I'm going to move up to Jupyter Notebook. Yes, you can see the predictions over here. So we're going to make the similar predictions. I'm going to create a new Python 3 file. Here I have imported all the necessary libraries. And then we have to create the data. So I'm going to come here and I'm going to say x is equal to pd.dataframe. So we're going to create a data frame here. And then I'm going to say boston.data and I'm going to say comma. I'm going to set the columns. And I'm going to set the columns to boston.feature names. Feature names. Name error Boston. Oh yeah, we made a small mistake. That is, we're going to say Boston is equal to the import Boston. So where's that? Yeah, load Boston. So do not worry about the code or the data set. I'll be posting it in the GitHub link below. And then we have to create the y value. So I'm going to say y is equal to pd.series with S capital. Do not miss this. It's going to show an error with S capital. And inside this, I'm going to say boston.target. Yes. So we have the x and y values. Let me show you guys. Here we're going to use the car dataset, car price dataset. Though the feature names are different, but it's all going to be the price dataset, car price dataset. So after doing this, after creating the x and y values, we have to split them up. So I'm going to say x train, comma x test, comma y train, comma y test is equal to train test split. And here we have the x and y. And then we have to specify the test size. I'm going to say 0.30. Yes, let's run this. So we have split it up. Now we have to create the regressor. So I'm going to say regressor is equal to, we have to get the import. Here that is the gradient boosting regressor. Let me get the import. Yes. So inside this parentheses, we have to put a few features like the learning rate. So I'm going to say learning rate is equal to 0.1. And then we have the n estimators. That's going to be, let's set it to 3. Yes. And then we have the max depth. Let's set it to 2. Yes. Yes. Then we have to fit this x train and y train. I'm going to say regressor dot fit x train comma y train. Yes. And after this we have to make our booster more strong. So we're gonna give the n estimators to the computer. It'll calculate by itself. Before that we have to calculate the errors for it. So I'm gonna say errors is equal to mean squared error of the y test and the y predict. And then we have to create a for loop saying for y predict in this regressor stacked. So we're gonna know how many leaves we need and everything. So I'm gonna say regressor dot stack predictions for the x train. Yes. Oh, here we have done a small mistake. We put it as x train instead of x test. And now we're gonna say best n estimators or n best estimators something estimators is equal to our minimum, the minimum argument over here, and we're gonna put up the minimum argument over here, and inside this parentheses we're gonna put the errors. So we're gonna get the minimum error, np dot, yes. And then we're gonna repeat the same thing. So let me copy this, but n estimators as n best estimators, or the best n estimators. Just add best over here. Yes. Estimators. N estimators is equal to best n estimators. And here we're gonna put best regressor. Yes, that's all. And then we're gonna fit it up. So I'm gonna say we're gonna say y predict is equal to best regressor dot fit x train and y train. Fit it? Yes. We're done. And now let me show you guys the predictions. Oh yeah, we have not predicted it yet. So I'm going to say y predict is equal to best regressor dot predict x train. And now you can see we have the predictions over here. So yeah guys, now we know what exactly is gradient boosted decision tree, and we have done it with a practical example. Thank you guys. Please do like, share, subscribe and comment below. Bye bye.